Hello, this is Mr. Collier, and today we're doing the vector product, also called the cross product. Okay, mainly because it uses this cross symbol. Okay, so the vector product of A and B is defined as A cross B equals the magnitude of A times the magnitude of B sine theta times the unit vector. So if we do A cross B, let's draw a picture. A cross B, what you get is a vector. You don't get a number, you get a vector that is actually perpendicular to both A and B. So this is A cross B. Okay, so it's very useful actually, especially when we get into 3D vectors. Here is, I don't know what says the magnitude of when we can use a symbol, but the magnitude of A cross B equals magnitude of A times magnitude of B sine theta. Alright, now the cross product is calculated this way. This is in the formula booklet for IB. I think of it as more like as this, and most people think about it this way. Because then this is more consistent, because in all three of them you're basically doing the same thing, except this one in the middle is negative. Okay, so cross product is defined for 3D vectors, only for 3D vectors. So you do the cross product, you get a vector that's perpendicular to both of them. Okay, now I'll show you how to do it here with this one. So if you do the cross product, basically what you can look at this formula in the IB formula booklet. But what you can do is you can ignore the first. Well, you're going to get a three-dimensional vector, so you're going to get three numbers here. The middle one is going to be negative. And what you do is just ignore the first row, and then you do 2 times 1 minus 4 times negative 1, which is 6. Next, I'll ignore the middle row and do 1 times 1 minus 2 times 4 is 1 minus 8 is negative 7. And then we have ignore the bottom row and do 1 times negative 1 minus 2 times 2. So that's negative 1 minus 4 is negative 5. So it's 6, 7, 5 is that vector. And use a scalar product to show that they are indeed perpendicular. So like I said, when you do the cross product, you get a vector that's perpendicular to both of them. So we can check that now with doing the dot product. So 6, 7, 5 dot, now we can check with both of them. 1, 2, 4 is equal to oh, sorry, that's supposed to be negative 5 over here. That's what the problem is. Okay, 6 times 1 is 6, and this is 14, and then we have negative 20, so it is indeed 0. And if you check with the other one, you also get 0, so they're perpendicular to both of them. Now here, it's the cross product's very useful because it's equal to the area of a parallelogram, and it's equal to, if you do half times the cross product, is equal to the area of this triangle right here. So it's also very useful for finding those areas. The proof is pretty easy. You can just drop down an h, like a height, right here. And the length of this side, or the length of h, is actually just, if we call this theta, then it is the magnitude of A, which is the hypotenuse side length, times sine theta. Okay, and the area of a parallelogram is base times height. The base is magnitude of B, and the height is that one there. Okay, and this is the property we talked about before, that just equals the magnitude of the cross product. Okay, so we're going to use these formulas now in the next couple of questions. Now, I was going to do this example with you, but it actually turns out that this doesn't actually even make a parallelogram, so let's do this example instead. Where we have 4 vertices, we're going to find the area of the parallelogram. So let's say A, B, C, D. And you take any two adjacent sides and get the area using those two vectors right here. Okay, so we use the area formula. It should be, the area should be equal to the cross product of dA cross dC. Okay, so let's get dA and dC first. dA is just A minus D. So that's going to be 1 minus negative 1 is 2. 4 minus 8, negative 4. 2 minus 9 is negative 7. Okay, and then dC is C minus D, which is 1 minus negative 1 is 2. 1 minus 8 is negative 7. 7 minus 9 is negative 2. Okay, so let's get the cross product now. So we'll do 2, negative 4, negative 7 cross 2, negative 7, negative 2. Okay, so let's ignore the first row and do 8 minus 49 is negative 41. And then the middle one's always negative. Ignore the middle row, we'll have negative 4 minus negative 14 is like negative 4 plus 14 is 10. Ignore the last row, we'll have negative 14 minus negative 8 is like negative 14 plus 8 is negative 6. So the area of the parallelogram is going to be root 41 squared plus 10 squared plus 6 squared. And this equals about 42.6. Okay, next we have given two magnitudes here, and that A and B are perpendicular to evaluate this cross product. Okay, so we have the cross product here. We have, we could use distributive property of cross product. So we're going to have let's do 2 times A cross A plus 2 times 3 is 6 A cross B minus B cross A, and then we have a minus 3 B cross B. Okay, now the key here is that we have a couple of cross product properties. A cross A equals 0 vector. Okay, that makes sense if you look at the definition of cross product. You're just going to have the same thing here and here, so you're just going to get a bunch of zeros. Okay, and also we have A cross B equals negative. If you flip them around, you actually get negative of that, right? Okay, but if you do this cross product, you get a vector that's perpendicular this way, and if you do the other cross product, you get a perpendicular vector the other way. So they're negatives of each other. Okay, so this is just a 0 vector, and here we're going to have 6A, cross B, and then we're going to have plus A cross B, and this one here is also 0, right? So that's the same as 7A cross B. Okay, but we have that they're perpendicular, so that means, well, let's use that rule where we have this cross this. Actually, I'm going to write like this. It gives you the magnitude of A times the magnitude of B, sine of the angle in between. So that is going to be, well, it's sine 90. Sine 90 is 1, so it's just going to be 7 times the magnitude of A, magnitude of B, and then we have those in the question, so it's 7 times 4 times 5, which is 140.